Not necessarily, but I want to get back into the habit for people who miss class, things like that. Go back to look at it and stuff like that. It's not really that hard. All right. For today, if you have not done so already, you will need the following. Something to write with. Sorry, you'll need a calculator as well. And a periodic table. So, something to write with, calculator, periodic table, and then the 3 new sheets that are over by the sink. So let's grab those things together and we'll get started. There are people who have
I'll show them.
So what do you use this? Illuminati. It was the Illuminati. She really I believe that now. I'm here. Bathtub at the hotel.
I mean,
You know, the parents someone that like in the bathtub.
yeah.
Well, like what happened?
This morning, TMZ was reporting that it was a lethal combination of alcohol and antidepressants. I believe is what they were overworking.
So I feel like
I mean, she had a pretty well documented drug problem.
I thought she was going to he told Oprah. Did they believe her?
What?
They told Oprah she was put the devils behind.
Yeah, but I'm not an addict. I'm not an addict, so I don't know. But basically, from what I hear, you're never really cured.
I know her daughter's 18 years old. Yeah, Bobby.
All right. Starting first, okay, up on the board is your calendar for the next 2 weeks. So, hey, come on, let's go. So, for the next 2 weeks, today we get started into the last part of the chemical reactions unit, and that deals with formula mass, and we'll see if we get into stoichiometry or not. We'll see. It might have to wait till tomorrow. Okay. Tomorrow we'll continue on with the stoichiometry ideas that we first introduced today, depending on how far we get. The lab report is due tomorrow, okay, so if you have any questions on that, make sure that we get those answered sometime today, hopefully. Then on Wednesday, the lab on Wednesday actually has some waiting around parts where we'll start it up, we'll do something to it, we got to let it sit and wait for a little while, and then we'll come back to it later. So we'll probably get the lab started at the beginning of the period, and then do some things in the middle, and then come back to it at the end of the period. That's planned for Wednesday. Then on Friday, we'll talk about the percent yield idea. So that's where it's scheduled right now, but we'll see how far we get. We might have to push that. We might have to push this quiz back to Wednesday. We'll just have to see how far we get. Okay? Next week, you guys are off both Monday and Tuesday. Okay? Monday is
My birthday.
President's Day, the day after that.
No, it's my birthday.
Sam's birthday.
I'm more important than
All right, and when we come back on Wednesday, we'll wrap up any stoichiometry stuff that we haven't talked about. Then Thursday, I will devote to review, and then your test is scheduled for next Friday. Okay, and that will be the end of our chemistry stuff. That will be our last chemistry unit. We'll move on to physics next week. Depends on who you are. So, some people really dig physics, some people really dig chemistry.
It's more like math.
This is a little more mathematical.
It's like chemistry.
This is totally chemistry.
It's like chem over taking if I take.
Well, I mean, you'll cover this and obviously a lot more, but yes. So that is our plan for the next 2 weeks. So we will wrap up chemistry next Friday. All right. The last part of our we said this last unit that we do in chemistry deals with chemical reactions. And the test next Friday will be a test over all of the chemical reactions stuff. Chemical reactions started way back with chemical equations and balancing equations, so that's where the test is going to start. Then we talked about types of reactions and things that you just took your quiz on. Okay. The last part of this unit on chemical reactions deals with stoichiometry. Stoichiometry is a funny sounding word, okay? But stoichiometry geometry. No, it's not, I don't think it's named after a guy. Alright. Stoichiometry deals with numerical relationships between reactants and products. So this unit, the next week or so, is going to be kind of a lot of math problems. It's going to be bringing together things that we've done up until this point. Formulas, average time of mass stuff, conversions, all kinds of things that we've done. It's going to be, bringing it all together, right? So this unit starts with something that we refer to as formula mass. On this sheet, on the front side of this sheet, up the top, there are 6 combinations of elements, and they're all metals and nonmetals. So we're dealing with ionic compounds. Okay? What I want you to do first is, based off of where those elements appear on the periodic table, how many electrons the metal is looking to lose, how many of the electrons the nonmetal is looking to gain, come up with the formulas for these 6 compounds. Okay? You don't have to do this by yourself. Talk to the person next to you. Okay? Let's get this done in the next 2 minutes. Go. Oh, it's... Roy likes the LS hat. I will slowly start putting answers up on the board, so if you want to check to see how you're doing, you may do so. The first one is up. Same color.
I do.
What if they ran out of paper 2 days before my birthday?
I don't believe it at all.
How many other things to the minus?
They're not. They don't even.
Do they have a track record?
What are people excuses for if they think it's true? What do people say? It's because the minus. I wonder what they think.
All right, up on the board. Up on the board are these six formulas for these compounds. Yeah?
Like lithium is one.
Magnesium is looking to lose 2 electrons, right? Okay. But how many can chlorine pick up? No, where's chlorine at?
Oh, wait. Chlorine is 7.
right? So chlorine.
And then you do. Okay, sorry, got it.
All right, so let's see where this takes us. Okay. Back when we were talking about elements and atoms and things like that, we said that we've developed a system that allows us to count atoms without actually having to count them. All right. We talked about these relationships. That 1 mole of something is equal to 6.022 times 10 to the 23rd atoms. Does that sound familiar?
Yes.
Good.
Good.
We also talked about the idea that if we have Avogadro's number of atoms, that equals a certain amount of grams. And where did we get that grams number from?
Table.
Periodic table. And we referred to that value as the molar mass. And we got the molar mass from the periodic table. It was numerically equal to the average atomic mass that showed up on the periodic table. And then, right, if 1 mole is equal to this many atoms, and this many atoms is equal to this many grams, right, then we can make the jump that 1 mole of something is equal to this many grams of that element as well. Okay? Now, these relationships are still going to hold true. We just have to modify them a little bit when we're dealing with compounds. Okay? If 1 mole of something is equal to this many atoms, if we're talking about an element, okay? Here, what is LIF telling you? If we write this formula equal to LIF, what is that saying to you? There's good elements. It's 2 elements, and what have they done? They've bonded together, right? Those 2 elements have bonded together to form a compound. Wrong way. Too far. If there are this many atoms in 1 mole of something, remember a mole is just a counting thing, right? There's always the same number of things. Could be atoms, could be race cars, could be whatever, right? But when we're dealing with this compound, we refer to this group, 1 lithium and 1 fluorine, as a formula unit. Does that sound familiar from a couple weeks ago? Okay. So, if 1 mole of something is equal to this many atoms, 1 mole of something is also equal to this many formula units. It's still just a counting thing, right? It doesn't matter what we're counting, it's still this many items make up a mole. Okay? Good there? Now we're dealing with looking at these relationships for compounds as opposed to just elements. One of the fun things about this section here is that, formula units shows up kind of a lot, but it takes, formula units is kind of a long thing to write. So instead of writing formula units, sometimes we can just abbreviate it as FU. So I'm sure some of you will find it.
Hilarious.
I think some of you will find it more like cathartic. You know what cathartic is? It's like a release of stress.
We can
all at
write it
one
in
time.
our lab report.
Exactly. Except this doesn't really apply to your lab report exam.
We'll make it apply.
So,
FU is a no.
okay. If we talked about that this many atoms is equal to a grams value equal to the molar mass, right? That same relationship is going to hold true, but now instead of having this many formula units, we now refer to this value as the formula mass. Okay? Calculating the formula mass for a compound is pretty straightforward. Okay? If we take a look at this compound, lithium fluoride, right, LiF, we know the mass of 1 mole of lithium, right? What's the mass of 1 mole of lithium atoms going to be? 6.9. Nope, that's how many lithium atoms are in a mole. 6.94. Okay. 1 1 mole of lithium atoms is equal to 6.94 grams. Okay? 1 mole of fluorine atoms, 19, depending on what, if you guys like 9.0,
I bet 18.
Say again. Depending on which periodic table you have, it's either 19.0 or 18.99, depending on how you count and stuff like that. Okay? Now, if we know that lithium and fluorine form a compound where there's 1 lithium and 1 fluorine, if we have a mole of those formula units, what are we going to do to figure out the mass of that many formula units? Just add the 2 molar masses together. Right? So the formula mass for lithium fluoride is 6.94 plus, depending on what periodic table you have, 19.00. Right? Add them together because, Sam, what we're just looking at is the molar mass of all of the atoms that are in that compound. Okay? And you'll notice down at the bottom of the page, there's 3 sections to this problem set. Okay? Down at the bottom of the first page, it says, calculate the formula mass for the compounds listed in 1 through 12. Okay? So, you take the mass of 1 lithium atom, you take the mass of 1 fluorine atom, and you end up with 25.94.
And you just write that back.
That's the answer. That's the formula mass. And the formula mass is it has a unit on it, right? It's going to be what? It's going to be grams. It's the mass of 1 mole. Okay? Chris, go ahead.
Okay. For number 2, it's K30.
That's number 3, actually, I think, isn't it?
Yeah, number 3. Sorry.
Okay. So,
Would that be
well, here.
3 acid test?
So, K20. Yeah. So now, if we go with number 3, just because that's the one you asked about, right? Okay. Now what we do is we take the mass of each atom that's in that compound, in that formula unit, right? So how many potassiums are there? There's 2. So it's 2 times the mass of potassium, which is 39.10. Okay. I think it's 39.10, right?
Yeah.
But then, how many oxygens do you have? There's only 1. So it's only 1 times the mass of oxygen, which is 16.00. And you add that together. Right. Yeah, you're going to add, yeah. So Sam, like you said for number 2, if this is magnesium chloride, right? Okay, it's 1 times the mass of magnesium, which is 24.31. 2 times the mass of chlorine, which is 35.45, if I remember correctly. And then, Allison, like you said, we're going to add those values together. That's good.
Well, why wouldn't it, like, I remember, like, a couple of years ago, we talked about adding the prefixes with an element that has more than 1 atom, like, why wouldn't it be magnesium dichloride?
Said that only applies, those prefixes only apply when we're dealing with covalent atoms, covalently bonded atoms, because when we're dealing with metals and nonmetals, like in this case, there aren't multiple possibilities for compounds that form between magnesium and chlorine. Okay? There's only 1 possibility for a compound that forms between magnesium and chlorine, and it's MgCl2. But when we're dealing with covalently bonded atoms or nonmetals, they can form multiple compounds that have the same elements in them, like carbon dioxide and carbon monoxide. They both have carbon and oxygen in different ratios. But when we're dealing with ionic compounds, that doesn't happen. So, go through and figure out the formula mass for these 6 compounds that we did up the top.
This one, I put it around to like 6.4.
You can keep 3 decimal places.
I guess they need to.
Don't worry about 16. Just
I thought it was, according to your PowerPoint.
yeah.
Yeah.
At this point, it's add up. So
next time, for the near future, we're going to have to deal with sig days.
we'll deal with sig days and all that.
Okay, sig days.
We'll talk about how to deal with sig days. calculate the formula mass for these 6 compounds.
Hopefully the next part will be
One more minute. That'll work. All right. So we got our formula mass worked out?
Yes.
Even if you don't have all of them worked out, if you just have like the first 3 out. All right. If we flip over to the back of this problem set, let's take a look at number 13. All right, so number 13 says, how many moles are in 24.56 grams of magnesium chloride? This is a conversion problem. A conversion problem similar to the conversion problems that we've done before. So we said conversion problems all start out the same way. What's the first thing we did when we were doing a conversion problem? Alice, go ahead.
You write down like half of 4.56 grams and you put over 1 and put times.
Hold on. So we're starting there, right? 24.56 grams of magnesium chloride. Okay? Good there? All right. Then, Allison, our next step was what?
Put it over 1 if you want.
You can put it over 1 if you want to. That's fine.
And then times fraction bar.
Time sign, fraction bar. Okay? Then, once we've set up our conversion factor, right? This is our conversion factor, or the skeleton of it, right? What do we do next? Okay, so Sam, where is grams going in this conversion factor? On the bottom, because we're trying to get rid of grams, right? So grams of magnesium chloride is going to go on the bottom. Okay, and then moles of magnesium chloride are going to go on the top. Okay? Yes, Elsa?
Why is it CO2?
Because that's the formula for magnesium chloride, right? It's number 2 on the front page.
Oh.
Right? Is that? Notice, Allison, you'll notice that this sheet I made up, like all of the formulas you use on the front, you end up using on the back. So, so anyway, now let's address where we go next. What did we say the next thing we did was in this conversion factor? After we've set up the units, what do we do? You put numbers in, right? What number always went in front of moles? 1 always goes in front of moles, right? That's still the case. When grams showed up in one of these conversion factors, what number went in front of grams?
6.022.
No, not 6.022. The molar mass went in front of grams, okay? Now, instead of being the molar mass, what number are you going to put in here?
FU.
No, not FU. We said if we go back here, you just wanted to yell that at me.
Yeah.
So, here, we said the molar mass gets replaced with the formula mass, right? The formula mass just being the sum of all the average atomic masses of the elements that are in that compound. On the previous side, right, at the bottom, you figured out the molar mass of magnesium chloride. Okay? 95.21, is that what it is?
Oh, what?
Number 2 is magnesium chloride.
Yeah, instead of, I wrote 2.
And so this, whoa, here is 95.21. Now, we just do a little math, right? Grams of magnesium chloride on the top, grams of magnesium chloride on the bottom. They'll cancel. And when we run these through,
0.25.
what do you think? So, Raj, right? When we do sig digs, we said these numbers in our conversion factor, these aren't measurements, right? These are just,
don't count.
those don't count. So we just match,
The original.
right? So how many sig digs are in that number, Raj?
4.
4. So our answer would be
1.257.125.
I got 0.255.
maybe you typed in this number once. Check and see what you actually typed in here. But
Yeah,
something like that seems like it only cost you like half. Alright, we good there?
yeah.
If we look again on the back side of that problem set, let's take a look at number 16. Number 16. Number 16 says, how many moles are there in 4.23 times 10 to the 34th formula units of lithium fluoride? So lithium fluoride, we've already established, looks like this. So starting off this problem, we started off exactly the same way, right? 4.23 times 10 to the 34th formula units, lithium fluoride. Time sign, fraction bar. Units-wise, what's going on the bottom of this conversion factor? Formula units are going on the bottom, right? Formula units of lithium fluoride on the bottom. And then what's going on the top?
1 mole. Or mole.
Units-wise, let's just go moles. So moles of lithium fluoride here. When we see mole in a conversion factor, what number goes in front of it? Plus 1. Now, when we see formula units, right? That's where we get back to the, oh, where are those?
6.022.
That's where we get back to the 6.022, right? 1 mole of something is equal to 6.022 times 10 to the 23rd formula units. Okay. So if we go back to our problem here, okay, that means I can fill in 6.022 times 10 to the 23rd here. Do we need the formula mass to do this problem? The answer to this problem is exactly the same regardless of what compound we're talking about, because moles and formula units have the same relationship for every compound. So you run that through your calculator, 4.23. Oh. For tonight, well, you might not be able to finish the whole worksheet because numbers 7 through 12 we didn't do the formulas yet on the front, but there are 4 problems on the back side that relate to the formulas that we figured out in class. I'll post them online as far as no, we're going to also check to make sure.